So, good afternoon. So, today we'll be doing organic chemistry, introduction to organic chemistry, alright? So, let's get cracking, alright? So, organic chemistry is the study of compounds that contains carbon. Alright, so organic chemistry. So the study of compounds which contains carbon, right? Right, so we know carbon, atomic number 6, mass number 12, right? So we know that 6 protons, 6 neutrons per shell, 2 electrons, and we have 6 electrons in total, so it's 4 electrons in the outer shell. Alright? So that's carbon compound, right? Now, carbon atom, it's very versatile. It can form 4 covalent bonds. Alright? Normally classified as a non-metal. You do have inorganic compounds which contain carbon, such as carbon dioxide, but those are not the ones that we're going to specifically study when we talk about organic chemistry, which compound which contains carbon, right? It's the compound which contains carbon covalently bonded to hydrogen, plus other atoms may be involved as well, such as oxygen, even the noble gases. Alright? No. So it simply means that a carbon can form a single bond between another carbon atom. So if we have using valence shell only, we have like a carbon here, can form plus another carbon. Alright, this bond, so we know we're not going to use the dot cross diagram when we're talking about organic chemistry. So like a bond like is a covalent bond between a carbon atom and another carbon atom. We're going to represent it as C-C. And we call it a single bond between carbon atoms. Alright. Also, if you note here, we could also have 2 pairs of electrons being shared between the carbon atoms. So this carbon atom here and another carbon atom here, we could have alright, so this is a carbon atom, this is a carbon atom. So this would be equivalent to C double bond C. Following? So I'm just moving from how we're going to use the shells to this, because we're not going to really use these bonding diagrams in organic chemistry. We're going to use this and this. Alright? Carbon, unlike most other elements in the periodic table, it can form lots of covalent bonds among itself. So it does not have to stop at 2 carbon atoms. It can go to 3, 4, 5, 6 carbon atoms. Alright? Etc. Right? And you can form a single bond, a double bond. You could also form a triple bond between carbon atoms. Right? And the term that they use to describe the ability of a carbon atom to bond covalently with other carbon atoms to form long chains and rings is called catenation. So this word ability long chains and rings, alright? You should be familiar with that term. So let me just give the definition of a homologous series. So a homologous series is a group of organic compounds which all possess the same functional group and can be represented using the same general formula. Right? So the important thing, 2 important points there to making the official definition. Same functional group. Group is 1 point. And they can be represented by the same general formula. And examples. You have 4 main examples that you need to cover for O-level chemistry, right? So you have 1, you have alkanes. We have alkenes. So remember that they have several homologous series. There are probably about 10 different series, but we're just going to focus on these 4 since it's the introduction. Alright, and that's what will be required for the syllabus. Those 4. Just put additional alternative names in bracket because sometimes they don't want to get confused if they will interchange the names in the exams. Alright, that when you're discussing it. Alright? So make note of that. Right? So now we're going to go functional group. So you can make a note of the functional group beside it. Alright? So for the alkanes it's a C single bond C. For the alkenes it's a C double bond C. For the alcohol it's a OH, so O-H, bond to a carbon, alcohol, and for carboxylic acid, a C double bond O, a single bond to the oxygen, then another single bond to the hydrogen from the oxygen here. Right, so this is in terms of the structure. Right? If we talk about alkanes and alkenes, if we have double bonds, we normally classify it as unsaturated. Alright, unsaturated hydrocarbons. And hydrocarbons is a word that we use to describe alkanes and alkenes and alkynes. So if you have compounds that contain only carbon and hydrogen, we use the term hydrocarbon to classify all of those homologous series which contains only carbon and hydrogen. So examples of hydrocarbon would be alkanes, alkenes, alkynes. Even though I'm not representing it here, but alkynes would be C triple bond C. Alright? I'm going to give you some prefix in which we will use to indicate the number of carbon atoms, right? So, number of carbon atoms and the prefix, right? A prefix part of the name that would go at the front. Alright? So we have number of carbon atoms 1, 2, 3, 4, 5, 6. Alright? Right? So we have met, et, pro, but, pent, and hex. Alright? Those are the prefix that we will use. Alright? Now, okay. Alright? Alkenes have the prefix. Following alcohol. So the prefix are similar to what I gave you in the table before. Meat, eat, pro, but. Alright? Plus anal. Alright, so organic compounds. Alright, so let's focus on alkenes. Alright, now the general formula CnH2n plus 2. Alright, and the functional group C21C. Alright, now. So for the first member, it would be when we have one carbon atom. Right? So if it's one carbon atom, it is ETH, and its name ending must be ANE. So this one carbon atom is going to be methane, ANE. That's the name. So alkanes are hydrocarbons, so it contain only carbon and hydrogen. Remember that alkanes and alkenes are hydrocarbons, meaning that they contain only carbon and hydrogen. Good? Second member would be C. Two carbon atom, the abbreviation that we use to represent two carbon atoms is last part A. So ethane or ethane, whichever pronunciation, doesn't matter. Alright? Then we have three carbon atoms. So these are the full structural formulas. This is how you represent the full structural formula in the exam. Alright? This is pro 3 carbon atoms, ANE, alkane. Right? We have 4. U, T, A, N, E. So take those two from the board. Right?
That was 2 carbon.
So 1, 2. So remember that a dash represents 2 electrons that is covalently in a covalent bond, single covalent bond. So it either can be between a carbon and a hydrogen, or it can be between a carbon and a carbon, but it's a single bond, right? 2, 3, 4, 5. So this is 10A, right? 6, 1, 2, 3, 4, 6. They are unlikely to give you greater than 6 in the exam. Alright? But you should probably know more. But no straight chain length of 6, the name, and you should define in terms of naming. Exhale. There? Now, these are the full structural formula, right? We technically also need to know about we are familiar with molecular formula and empirical formula already. So technically, we should be able to write molecular formula and condense.